Welcome everyone. First of all, thanks to the XtremePython community for conducting the XtremePython uh, conference. I know like we have moved into a lot of in-person events, but I still feel that remote conferences are still a great way for people to connect, especially if you're not able to come to a physical location. So I'm grateful that we're still having remote and virtual events. I got the opportunity to also present at Extreme JS a couple of weeks ago. So super excited to be talking today about how you can create generative AI applications powered by Streamlit and using open source large language models. And a quick introduction about myself. I'm Shivay. I'm a developer advocate at Pieces for Developers. Pieces for Developers is a really exciting company where we are building the next generation of tooling for helping improve developer productivity. So right from very intuitive generation of code snippets that have a lot of metadata around, where who actually wrote that particular code snippet, um, all the way to also, using copilots powered by large language models, both uh, cloud-based such as, uh, Gemini or ChatGPT or GPT-4, to also then having a huge focus on using open source large language models like Llama 2, Phi, and Mistral, so that you can empower your developer productivity with the help of these tools. So I'll speak more about that in a bit and how we can leverage some of the open source SDKs that are there powered by pieces that you can leverage to essentially create a wrapper around leveraging these large language models and get capabilities like retrieval augmented generation as well. And of course, it's completely fine if you are new to this entire era of AI and you're still kind of in that process of either learning what is AI and how to implement AI with Python. So this is going to be a very beginner friendly session for all of you. So without wasting any further time, let's get started. So of course, we are in this era where if I were to draw a word cloud and ask all of you that what are some of the most trending technical topics that all of you might have heard. So you must have probably heard of ChatGPT because it blew up in popularity, especially in 2023, and that also gave rise to these terminologies like generative AI, retrieval augmented generation, large language models, fine tuning, BARD, Llama, right? All of these different terms really grew in popularity over the last 1 year. And of course, if you are following AI news, you'll essentially find that we are getting like new large language models every single day or every single week. Google, OpenAI, these are some of the big companies that have released, open source models and also like proprietary models like GPT-4, GPT 3.5, Gemini, and then also at the same time we have a huge number of open source large language models that are getting released, including models like Gemma from Google. Then we have, Llama 2 from Facebook or Meta, and then also we have like hugely popular Mistral models that are getting released. And here, as you can see, like in these news, like we are literally getting a new large language model. And we are getting like different flavors of large language models as well. Those are primarily like focused towards like, let's say, just text. You'll have large language models that are just for generating images. We just had like a recent launch of Sora or an announcement of Sora, which is a text to video generation. So you're just seeing all these generative models that are coming up that are trained over large amounts of data. So of course, the biggest question that comes in then, how can we as software engineers leverage these large language models in case like you haven't ever heard of these, how we can leverage those. So yeah, essentially that's what we're going to be covering in today's session. And if you have any questions at any point in time, do let me know. I'll be more than happy to answer any questions that you might have during the session. But yeah, of course, just to kind of give an idea for someone who has just gotten into generative AI. So generative AI, or as a lot of people like to call it as Gen AI, is essentially the artificial intelligence or a category of artificial intelligence that allows you to create new content such as text or images. Now, foundational machine learning models are generally used to do predictions. So you do a lot of like predictive analysis. Like let's say if you're having different images of dogs and cats, you'll use a typical model like linear regression or something like, let's say, a k-means algorithm to detect, okay, whether an image has, whether it contains an image of a cat or a dog. So you'll basically get a response as a label for that image. So a lot of the existing machine learning models are mainly for doing prediction and giving you results. But especially over the last 10 to 15 years, we have seen a huge rise in models that allow you to actually generate something. We kind of started to see that with the introduction of GANs, which are generative adversarial networks, which were used to generate like images using an existing image data set, and it is capable of generating new images. And now we are just seeing these highly specialized Gen AI models, and we are also seeing like multimodal models where you can essentially use the same model to generate text, to generate images. So we are just really in that kind of a space where we are now moving from predictive analysis to also then generating a lot of different things with the help of AI, whether it's generation of songs or images or text, right? So I think like that's one of the most impactful things that we're seeing these days. And of course, these models, these foundational models have so much amount of training data on which they have been trained that you don't really require any additional training or fine tuning by default. Of course, you can still make them more adaptable to your own use case, but they are generally ready to go, and you can start using them. But of course, we have been using the term LLMs, large language models, a lot, right? So, what are LLMs in the first place, and how are they different from your general machine learning models like a KNN algorithm or a k-means algorithm? So, the generative AI uses large language models because they are essentially an extension of your typical neural networks or deep learning algorithms that have been trained over a lot of data, right? When we say a lot of data, then you are essentially looking at billions of documents. There has been a case study around how the training for GPT 3.5 and GPT 4 was used. Generally, these models have a very large amount of data that you are basically training them on, and of course, like that can range, from millions and billions of different documents. Whereas if you look at traditional machine learning models, they are pretty small, right? And if you take a look at standard deep learning, like standard deep learning systems, like either the convolutional neural networks or RNNs, recurrent neural networks, they are just basic structures of deep learning, right? And of course, these large language models are highly customized implementations of these models, and that is why they are a lot more complex, and they have been trained over a lot of data. And that is the reason why they are able to answer any sort of question that you put your way. They're like, for example, the specialized large language models that have been trained over a lot of code. For example, GitHub Copilot, which is a tool that allows you to ask any questions to it regarding your code base, has been trained over the millions of different GitHub repositories that are there that have code in them, right? Open source repositories. So that is why like these large language models are really capable of being able to do a lot of different things. But yes, that comes with one of the, not really a disadvantage, but something just to keep in mind, which is that they require a lot of compute. They require a lot of RAM because they're just very heavy models. But we have seen that a lot of these models are being now, because these large language models are extremely diverse in their size, mainly depending on how much data on which they were originally trained. So some of them can also actually run on embedded devices. So you can technically run them on something like a Raspberry Pi or a mobile phone. And of course, like some of them are fairly big that require you to have dedicated GPU, in order to compute them efficiently. But of course, like we'll not focus on a lot on that part, but let's proceed further. And of course, like, at the same time, while we have had these large language models come up, we are just seeing Gen AI adoption every single where, whether it's, LinkedIn now having the capability to write a post with the help of AI, or Gmail allowing you to add like automatically add content for your email with the help of the Gen AI functionality, or you're using tools like GitHub Copilot or pieces Copilot for that matter in order to generate code for you or ask any question regarding your code base, or just integrating like AI in software itself. A lot of like mobile phones with mobile OS that are getting released are adding like generative AI features directly inbuilt into the operating system itself. So the adoption is going crazy right now. So of course, the biggest question rises is that for regular software engineers who might not have a lot of AI experience, how can you leverage applications, or how can you leverage these Gen AI features in order to build generative AI applications? Because for someone who does not have a lot of experience or has never probably worked with machine learning or AI, how can you do that? So the answer is that there are a lot of different tools that you can leverage today that have made it extremely easy for even someone who does not come from a traditional machine learning background or AI background to leverage open source tooling to build generative AI first applications. And the first thing that I'd like to kind of introduce is Streamlit. So Streamlit is an open source Python framework for AI engineers and data scientists to create dynamic data applications that can be very easily deployed in the web. And they essentially, you turn your standard data scripts into shareable web apps, because one of the major issues when dealing with something like your Jupyter notebook or Google Colab notebook is, yeah, like, I mean, you can write that code and you might get your model to work and the model to train and to do the inference, but how do you share it with everyone, right? And Streamlit is a very powerful tool that allows you to just convert those boring, non-shareable Jupyter notebooks into shareable web apps and still get the capability of doing things like training and then, showing the execution of your models. So I'll definitely recommend everyone who has even the slightest inclination towards machine learning and AI to at least try out Streamlit. It is a very powerful framework. And in fact, like there is a dedicated section now within Streamlit that allows you to leverage the Gen AI capabilities, and that gives you a lot of inbuilt components that allow you to do things like generate or create like a chat GPT style open machine learning based chat application that can you can very easily replicate like a chat GPT style application. But of course you can build a lot more. For example, you could build like a readme generator where you give a code source code file and you just ask the AI that, hey, help me generate a very intuitive readme, or help me like, let's say if you're working on an open source project and you want to automatically generate a commit message based on the file changes that are there in your git diff, you could do that with the help of generative AI. And those are kind of applications that you can very easily build with the help of Streamlit, because it provides you ready to use components to build those kind of applications. And while not having to learn any HTML, JavaScript, CSS, all written in pure Python. So just to kind of give you like an idea of how that kind of looks like, I'll just quickly open up, the particular section for the Gen AI features that we have. So like this is the official Streamlit application over here. And then, you can essentially just create things like building your own chatbot in a matter of like just, 30 lines of code. You can get this kind of a chatbot. Or if you want to like create like a blog outline generator app, where you give like a prompt that, hey, I'm writing a blog about something, and then you can easily like get those. So this is like a really nice example, and in fact like there is a community section as well where you can see some other examples that the community audience have built or the community members have built. And this is what we are going to be covering, that how can you leverage Streamlit in order to build your generative AI applications. So that's what we're going to be covering in today's session. But that I'll quickly also introduce like, Pieces. So Pieces, as I already covered, is a AI powered developer tool that really helps you to boost your developer productivity. So whether like, let's say you're doing research online and you find certain code snippets that you might want to use in your application, so you can very easily save those. But at the same time, now you maintain the context around what research that you did. So now let's say if you switch over from research into doing hardcore development with VS Code, you can very, very easily access those code snippets that you just saved during your research and you get capability of a experience which is kind of similar to something like a GitHub Copilot, which is the Pieces Copilot that can answer questions for you based on your code. So you can set context around a single code file or an entire code base, and it can answer questions right from and these can be powered by local large language models like Mistral. So you don't need like a GitHub Copilot subscription. So that's one of the great features of Pieces Copilot. Now, under the hood, the Pieces application and the Pieces Copilot are being powered by what is known as the Pieces OS. It's a background service that runs on your device, and again, completely local on your device. And it supports a lot of the different large language models for you to choose. So if you choose the on-device, models, you can leverage like open source models like Mistral, Llama 2, Code Llama, Phi 2, and of course there is upcoming support for Mixtral and Gemma. Now, the Pieces OS itself, is kind of running as a background service, but there are SDKs that are there, open source SDKs that leverage the APIs that allow you to basically interface with these large language models. So you don't need to run these large language models on your own. You can leverage the SDK, the Pieces SDK, to interact with these large language models. And I just saw like there is a question from Yanev who asks, it works like DALI but open source. So yes, in a way, for example, all these large language models like Mistral, Llama 2 are all open source. And this also means that you're not actually sending your data to something like a GPT or to a chat GPT or Google Gemini, because a lot of companies, developers have this concern that if we are sending our data to OpenAI, they might use it, right? And for those folks who are conscious that they want to do everything, all that inference locally in their system, they can use, these large language models, open source LLMs, locally on device. Now, yes, given that not everyone will be able to run them as efficiently, you still need some amount of compute. But a lot of these models generally have support for both CPU versus GPU based models. So like Llama 2 comes with Llama 2 CPU, Llama 2 GPU. And, we are seeing a lot of further optimizations to truly make running large language models locally, as seamless as possible. So a lot of optimizations generally we use like quantization techniques in order to make the size of these models smaller while still being able to run them. And you can use techniques like WASM, WebAssembly in order to run them on edge devices as well. But the great thing about at least running them with Pieces is that you get a lot of out of the box capability where you don't have to run these large language models yourself. You can just leverage the APIs and interact with them directly. How it kind of works is that we use WebSockets to connect with Pieces OS and then use the underlying large language model, and that's what we'll use in order to build our demo. So you can essentially pair Streamlit with the Pieces Python SDK to create intuitive generative AI applications. So whether you want to build your own README generator app where you upload a bunch of files and you automatically want to generate a README, or you want to build your own ChatGPT style application, a chatbot where you can interact with an open source large language model, you can very easily do that by combining the power of Streamlit and the open source Python SDK offered by Pieces. And without wasting any further time, let's get into a bit of a hands-on demo to give you a first glimpse into how all of this kind of works. So I'll go into my VS Code, where I'll quickly talk about first the Streamlit bot that I have built, and I'll also just share like a further recording of how all of this kind of works. You can actually take a look at this on our open source repository, which is called as the Streamlit bot Pieces, and you can quickly take a look over here, which is the Streamlit Copilot example. I'll quickly just share this code as well over here in for everyone to kind of see. I'll just quickly share this for everyone. So I'll just quickly jump into first explaining what the code does. And in fact, I'll first walk over the actual application itself. So in order to run any Streamlit application, you typically use the command Streamlit run and the name of your file. and that opens up a new Streamlit application on localhost 8501. So in this case, like this is my application that I'm running right now. This is my generative AI application. And what you see over here is that I can choose like any model. For example, I can choose between models like GPT-4, GPT 3.5, Gemini, right? I can choose between all these models. So let's say if I choose something like a GPT-4 model, and I can ask it, write a Python function to create a new WebSocket. And now we'll just wait for it to respond. So as you can see, in just a matter of a few seconds, it starts to give you a response, and it shares that, hey, here's a simple example of a Python function to create a new WebSocket using the WebSockets library. And here it will give you that code by asking that same question. Now, of course, what you see over here is we chose like these are all the different models that are the actual not the on-device models, but these are the models that are the cloud-based models. But you can also choose between the cloud-based models or even your local models as well. So this particular example, I'm just showing the all the cloud-based models, but you can also very easily tweak the code to render all of the local models as well. So this is like a quick example, and you can ask it a follow-up question that how can I close the WebSocket, right? How to close this WebSocket. So you can ask it like a follow-up question, and it will be able to answer that very easily, right? So you can see that it maintains the context for it in Python, and then it defines the code for closing that particular WebSocket request. So if, like now, if you're wondering like how do we create this application? So first, I'll just quickly give like an introduction to like how do you actually leverage Streamlit. So first of all, like some of the things to keep in mind, like the main requirements that we're using over here is we're using the Pieces OS client. So this is our official Pieces Python SDK, and we're using the Streamlit Python package. So the main source code that lies is basically in the pieces-bot.py, where we have imported our Streamlit, right? And now what you'll see over here is that we will talk about all of this code till line number 29 in a bit. But first, let's talk about the Streamlit UI, which is basically rendering this application. So what you'll see is, like, for example, we have given the title for our application as the Pieces Copilot Streamlit bot by using ST. So ST is what like is the Streamlit over here, the Streamlit object. And we are using the particular function to define the title. And that is what basically renders over here, which is the Pieces Copilot Streamlit bot. Then we have given it a URL and the image. So this is the image that gets rendered for this Pieces Copilot Streamlit bot. And then what we are basically doing is we are particularly leveraging one of the generative AI functionalities that has been given to us by over here, which is basically the ability to build a chatbot. So over here, what you'll see is that we have a title, and then we maintain this Python list for the messages. So this is where the messages for our conversations essentially are taking place. So whether you're having so you essentially say see two different roles over here. So one role is that of the assistant, and the other role is that of the user. So in this case, the first thing that we start off with is the first thing that we push to our list over here is that ask me anything about whatever you want to ask, and that is the first thing that actually gets rendered. Um, so if you see over here in my demo over here, right, the first thing that gets rendered is me ask me anything by Pieces Copilot. So this is the first message that is getting rendered by Streamlit, and that is why it has the role of that of the assistant. And then it basically asks you that, okay, now I want the user to basically ask the question. So that is why you see over here that we have the Streamlit.chat message as the function where we ask the user to send in their query. And that is what I'm actually writing my query over here. And as soon as I write my query, we essentially just append that to the messages, to the messages list. And that is why like whatever query was asked by the user, that then shows up over here. So if I just quickly refresh this and ask my first question, which is, hello, how are you? Let's say. So that basically gets appended to that message, and that is what is being happening over here, right? So we keep on appending the first question that the user asks, and then the subsequent responses that our assistant gives to us in this Streamlit session state messages. So all of this is inbuilt components that you're getting from Streamlit. So this kind of inbuilt chat application, is a very powerful example of just using out of the box functionality given by Streamlit, right? And all of this is given to you by default. You can leverage this example that is there on the Streamlit docs in order to build your own. So in fact, like all of this code, technically will not take you a lot of time because you can leverage that. Now, of course, where Pieces comes into picture, right? The Pieces OS SDK, which is leveraging these large language models, because right now Streamlit is only providing you the capability of, having all these UI elements. But now, of course, how do you interface with large language models? So that is where the code, which I'll just talk over, which is basically using the Pieces OS client. Now, the Pieces OS client, as I mentioned, it is a background service, and I'll just quickly show you. So I'm actually running this over here, which is the Pieces OS, which is running, as a background service. And now, how you interface with it, like basically the Pieces OS runs on localhost 1000. So if I just quickly go over to, the localhost 1000 quickly over here, you can see that, this is where we are basically running it. And all of the endpoints and how we are basically connecting with Pieces OS that allows you to, connect to the large language models is going to be leveraging the Pieces OS SDK. So we have the Pieces OS Python SDK that you can leverage. So I'll just quickly share that with you, which is this Pieces OS SDK for Python, which all of you can leverage and install and use for creating your own generative AI applications. And I'll also answer some of the questions that Chaim you've asked in the chat just in a bit. So this is what we're going to be using. You just have to install this particular SDK. And in order to now start using it, essentially what it basically does is that since your Pieces OS runs as a background service, we are using WebSocket connections to basically interface with the Pieces OS. And the Pieces OS is what is helping us to interact with the large language models directly. So over here, what we are basically doing is that I have a separate, section over here within the API, which is the Pieces WebSocket, that allows you to actually connect with Pieces OS. So the first thing that you'll see is that, we open up a WebSocket connection in order to connect with Pieces OS. And then, of course, we start the WebSocket connection. So this is where, we are just starting that WebSocket connection to start sending in the message, right? So whenever you're basically sending now a message from your Pieces over here, which is defined, we are basically starting a new connection over here, which is like you can see that whenever you're sending in a query, we are basically sending a model ID and our query. And we are opening up that connection to the Pieces OS so that it gets that query that you have sent, uses the appropriate large language model to, input that in the query and generate a response for you. And we have basically used a particular endpoint over here, which is the model snapshots endpoint, which basically lists all the available list of LLMs or the large language models that are available for us to use. So that is why you see that, this particular code over here, which states the model ID and like we iterate over, the model.cloud, this basically shows you all of the cloud-based models. And, you also have like all of the ones that are the local models. So you can see over here that the default model that we have chosen is the GPT 3.5. And we list all of the models over here in our Streamlit, which has been mentioned over here, like, the selected model. So this is using this models snapshot endpoint that lists all of the different endpoint, all the different models that you have, and you can leverage them. So that is the thing that you basically see over here, in the actual demo, where all these list of models are getting rendered by the actual, snapshots endpoint. Now, the major brains behind what's actually happening is and how we are basically generating the response, which is over here, which is using the write stream. So this write stream function, is basically what helps us to generate. So if I say write a Python program to add two numbers, right? So we are using the generate stream function from Streamlit, which basically renders this actual function. And internally, right, what we are doing is we are opening up a new WebSocket connection, and within our WebSocket connection, right, we are basically sending that particular message. So this is a response, or this is a request body of a message where we have sent the query. So this query is what we are inputting over here, right? So this is our query: write a Python program to add two numbers, and we are sending apart from that a model. So in this case, the model that we sent is, the whatever model was selected. So in this case, like I had selected the GPT 3.5. So that is the model that has been sent to our conversation. And now what you'll see is that we are basically just generating the actual message, which is leveraging a particular endpoint, which is the QGPT stream output. And here we are just sending our message, which basically contains our, our query. So this QGPT endpoint is basically the endpoint that's provided by the pieces, SDK, where the query that has been sent and the particular large language model that has been sent, we'll use that together to generate the response. And all of the response is getting generated over here that we then iterate over and send back to our Streamlit client. And that is what gets stored over here in the response section. And then we append our response from the assistant, and that is what essentially generates this response, right? So the specific endpoint that we are basically using is the QGPT endpoint, and we have like docs as well for all of the different endpoints. So the one that we are using is basically the QGPT, like output, which basically helps us to generate the output for a large language model. So this is like one example. Now I'll quickly also show you the other example, which is a README generator. So I'll just stop running this particular application quickly, and I'll just ensure that this is closed. And I'll actually go ahead and run this particular, application, which is a README generator. And I'll just go ahead and actually run this code as well. So this is also built using Streamlit. And here what we're doing is that we have already given a prompt, to our endpoint. So if I just quickly show you the application, what we are doing over here is we are basically telling the user, and first I'll just, describe over here. So let's say that I choose a bunch of files. So I'll go to my desktop, and let's say if I go to this vector search, I've selected all of these different files, and I want to create a README for this project. So I'll just describe, write a README for this project on vector search and Next.js. So I choose all these files and I click on generate. So this will hopefully generate a README for me. And you can see like all the different files that are there. And I'll just ensure that hopefully this works. So, I'll just click on generate, and hopefully, it will start to generate this for me shortly. It might take a few seconds to generate, because it's as you can see, like it's running, and of course, like generating a README can take a lot of time, can take a bit of time. So it's running right now, and hopefully like in a couple of seconds, like it will generate that actual README. And then you can, as you can see, so here you can see that this is project title is vector search with Next.js. This is a project that uses Node.js and uses libraries like LangChain, OpenAI. It gives you all of the steps to actually install this, and gives you like the contributing guides, the credits, license, and you can actually download this as a Markdown file, and take a look at how this Markdown file is actually generated. So I'll just quickly open this up, this particular Markdown file. So this is like pretty nice feature, right, where you did not have to generate the Markdown file on your own. And so you can see like this is the generated README that was created by the actual by the QGPT endpoint. And one of the really great use cases over here is that the main difference between this sample application that I showed you versus the one for just the QGPT endpoint for the chat application that I showed is that you can actually add additional files to the context. So what you see over here is like the way that we implemented over here is that we first gave a prompt to our to the system, or to the QGPT endpoint, which is like act like you're a programmer and generate a README for the project, and then what all things you should have in that particular README. And then the files is for uploading the files. And the great thing now that we are also adding over here is in this case we are using something known as a relevance QGPT seed. So this endpoint allows you to add relevance to your prompt, right? So for example, generally what you'll see is that if you ask a question to ChatGPT, it can give a very vague response. Now, in order to make the responses from your large language models to be more specific, you can add files as well, and you can use all those files as a context for your large language model to generate a response that is suitable for that specific context. So this is an example of like a RAG, which is like adding context to large language models. So in this case, what you're doing is that all of the files that get uploaded are getting added as relevance to our model. So that is why what you see over here is that when we are asking a question, right, we are basically asking it a question, which is the QGPT question endpoint, and then we basically generate a response by sending the data, which is our prompt, and the relevance. In this case, the relevance is all of the files that we have added, and of course the model ID, right, which we did similar to in our previous example as well. So you can choose between the different type of models, including like the Llama 2, for example, like the Llama 2 model as well. So in fact, like I don't want to close my internet connection, but if you didn't have internet connection, you didn't want to use GPT-4, you could use something like a Llama 2 model, and that would work locally in your system, and you can also leverage that. So this is like the beauty of leveraging Streamlit as this UI application platform and then interfacing it with generative AI features. And again, like there are dedicated guides that we have online if you're interested, to understand like what is this QGPT endpoint, how do you leverage it, right? So there are like dedicated guides that are written in TypeScript. We're also now writing them for Python as well. So if you're like, for example, if you're interested to take a look, we have a dedicated open source repository where we have linked all of the different SDK docs, then all of the different SDKs, some of the starter projects, and some guides on like, let's say, how do you build your own copilot? How do you like use custom context? And we have a dedicated YouTube video on just the copilot, and I'll just quickly show that over to you. So in the video section, we have a dedicated pieces copilot Streamlit bot that kind of goes on a that goes basically line by line into how we implemented that particular code. So feel free to like take a look at that particular video as well. I'll just share this for everyone's reference if everyone is interested to kind of take a look at that. But yeah, the capability that we have to offer, like by leveraging these tools, you can truly like build any sort of an application, right? As you can see on the Streamlit example on their website, if you want to build like a knowledge based GPT, if you want to like read over your own docs, you can do that. So the sky is the limit when it comes to like building intuitive generative AI powered applications. So that's a quick overview of what I want to kind of cover, at least with respect to the demo. And I'll of course like take over some of the questions that you might have. But definitely like follow all of these different links. Feel free to take a screen grab. We have given you the the generative, like the Streamlit GenAI functionality over here. And of course, feel free to also take a look at our Discord, because our Discord is a vibrant community to learn how to build generative AI applications. And even if you're not interested in pieces itself, like if you're just interested in open source in Python, it's a very vibrant community where we have like a dedicated open source section where we have discussions around like AI, around Python, around different languages as well. And so it's a very intuitive use case for all of you to kind of take a look. And I'll definitely recommend all of you to join the Discord server. I'll also share the link for everyone to kind of take a look, for everyone to kind of go through it. And I hope like everyone learned from this particular use case. And yeah, feel free to go through it, and I'll be open to questions now.